Hello everyone, welcome to my channel. In this video, I'll explain you the concept of supernodal analysis and few examples on it. When a voltage source is present between two nodes and if we remove the branch having the voltage source and then the nodes that are connected are reduced to a single node which is known as a supernode. This is the meaning of a supernode. Under the concept of nodal analysis, we may come across two cases. When voltage source is connected between one reference node and non-reference node. And another case is when voltage source is connected between two non-reference nodes. And procedure to be followed in this concept are: first step is to identify the total number of nodes. Second step is to assign the voltage at each node. One node is taken as reference node. Step 3 is to remove the branch having common voltage source between the nodes and apply KCL to supernode. Step 4 is to write the net voltages in voltage sources. And step 5 is to solve the KCL equations to find the node voltages. Now let us solve two examples on this. First problem, find the value of current I using nodal analysis. Step 1 is to identify number of nodes. Node is a common point where two or more elements are connected. Let's start identifying the node points. This is the point where three elements are connected. I will number this as 1. This is a common point where three elements are connected. Let this be node 2. And let this be node 3. Let this be node 4. So number of nodes equal to 4. Step 2. Assign node voltages. V1, V2, V3 and V4 are assigned node voltages across each and every node. And take one node as reference node. V4 node is considered as reference node. Let it be ground. Okay. Step 3 is, from figure, voltage source is present between a non-reference node and a reference node. Right? You can see 10 volts voltage source is present between a non-reference node 1 and reference node 4. So we can directly write here V1 equal to 10 volts. As V4 equal to 0 volts, so this voltage drop, that is voltage across node 1, will be 10 volts. V1 equal to 10 volts. Let this be equation number 1. Now apply KCL at node 2. We have three node voltages. We should find three node voltages by using KCL equations. So we need three equations to solve three unknowns. Let me apply KVL at node 2 and I am assuming that here all currents are leaving. According to the statement of KCL, sum of currents entering equal to sum of currents leaving, or sum of the currents at the junction is equal to 0. As I have assumed that all currents are leaving, I can write this as I1, I2 and let this be I3. I will write I1 plus I2 plus I3 equal to 0. I1 can be written as V2 minus V1 divided by 1. I2 can be written as V2 divided by 4 plus I3 can be written as V2 minus V3 divided by 3 equal to 0. Let this be equation number 2. We need one more equation to solve for V1, V2, V3. So I'll apply KCL at node 3. And as the current is entering here, let it be the same way I3. And I'll take this branch current as I4 and this branch current as I5. I5 is nothing but I. Applying KCL at node 3, I can write this as, from the figure, V2 minus V3 by 3, current entering equal to current sum of currents leaving, V3 minus V1 by 2. Let this be equation 3. Last step is, we have got 3 equations to find V1, V2, V3, and next step is to solving equations 1, 2 and 3. We obtain node voltages as V1 equal to 10 volts, V2 equal to 7.5 volts, V3 equal to 5.62 volts. What is the question we have? Find the value of current I using nodal analysis. From the figure you can see I is nothing but I5, right? So we are supposed to find the value of current I using nodal analysis. So I5 value we should find now. I5 can be written as V3 divided by 2. You can see according to Ohm's law I equal to V by R. I5 equal to V3 divided by this V3 divided by 2. V3 value is 5.62 volts by 2, which is equal to 2.81 amperes. Therefore, I5 equal to 2.81 amperes. This is the answer. Let's see next problem. Find the power delivered by 5 amp current source in the circuit shown in figure using nodal method. This is the circuit given to us. First, identify whether the circuit comes under concept of nodal analysis or supernodal analysis. If you see a voltage source is connected between a reference node and non-reference node, or a voltage source is connected between two non-reference nodes, you consider that problem as supernodal analysis. Step 1 is to identify number of nodes. Node is a common point where two or more elements are connected. I'll consider this as 1, this node as 2, this node as 3. Here this is ground given, no need to take it as separate node. Number of nodes equal to 3. Step 2 is to assign node voltages. At node 1 let it be V1, at node 2 let it be V2, at node 3 let it be V3. Next, step 3. From the figure you can see that there is a voltage source between node 1 and 2. That is, voltage source is connected between two non-reference nodes. Therefore, nodes 1 and 2 forms supernode. Apply KCL to supernode. Applying KCL to supernode. Here we have a current source leaving, let it be leaving. So here I am assuming the current is leaving, let it be I1. And even here I am assuming current is leaving, let it be I2. And here you can clearly see 5 amps is entering. and let it be in this same direction, and I am assuming that here in this branch current is leaving and it is I3. While applying KCL, we'll just write sum of currents entering equal to sum of currents leaving. Let me start with this branch now. So 2 plus I1 plus I2 and plus I3 equal to 5. Sum of currents leaving equal to sum of currents entering. I can write I1 as V1 minus V3 divided by 3. I2 as V2 minus V3 divided by 1. I3 as V2 divided by 5 equal to 5. I'll rewrite this equation as 0.34 V1 plus 1.2 V2 minus 1.34 V3 equal to 3. Let this be equation number 1. We have node voltages here V1, V2, V3. In order to obtain 3 unknowns, we require 3 equations now. And I'll apply KCL at node 3 now. Applying KCL at node 3. I1 we are assumed that here it is leaving. So it is leaving here. Let it be in the same direction. Even let it be in the same direction here. I'm assuming this as I4. We can write here sum of currents entering equal to sum of currents leaving. I can write I1 plus I2 equal to I4. I1 can be written as V1 minus V3 divided by 3. V1 minus V3 divided by 3. I2 as V2 minus V3 divided by 1 plus, equal to I4 as V3 divided by 2. By rewriting this equation, we can write 0.34 V1 plus V2 minus 1.83 V3 equal to 0. Let it be equation number 2. Next step is to write the net voltages in voltage sources. Step 4. In the circuit we have a voltage source 10 volts. Node 1, node 2. Net voltage can be written as V1 minus V2 equal to 10. Let this be equation 3. The node which is to the positive terminal, this node is greater than the other node voltage. So we have positive sign here. So V1 is greater than V2. V1 minus V2 equal to 10. We have got sufficient equations to solve for V1, V2, V3. Next step is to find solving equations 1, 2 and 3. We will get node voltages as V1 equal to 13.72 volts, V2 equal to 3.72 volts, V3 equal to 4.567 volts. These are the node voltages obtained for the given circuit. In the question, we are asked to find the power delivered by 5 ampere current source in the circuit. So power delivered by 5 ampere current source. Power delivered equal to voltage into current. V equal to I. Current flowing here is I. Voltage across this current source is V2. Power delivered by 5 amp source is given by V into I. There we have V2. V2 obtained above is 3.72 into 5 equal to 18.6 watts. This is the final answer. That's all for this video. Thank you.